Okay, guys, let's look at how we can find this our definite integral, which is the limit as n goes to infinity of the integral from 1 to n natural log of x over n natural log of n dx. So guys, as you can see in this case now, n in this case is the constant because we have to integrate with respect to x. Wait, so x in this case is a variable, then n is a constant, guys. And after finding the integral, we now have to take the limit. So let's do one step at a time, guys. So in this case, we're going to have the limit as n goes to infinity of, okay, now the integral of, now guys, what this guy simply means is that since n in this case is the constant, we are simply going to take it outside of the integral. We're not going to have, I can open a bracket here to write 1 by n natural log of n. Now guys, into, we have now natural log of x with dx. So guys, that's what this guy simply means. So in this case now, n is a constant. We are going to integrate natural log of x dx, natural log of x dx. As you all know, guys, the integral of natural log of x dx, we have it to what? X ln x minus x. Wait, so this guy turns out to be the limit as n goes to infinity of integrating this guy from 1 to n. Guys, this simply gives us, we are going to have 1 over n natural log of n into, this is going to be x natural log of x minus x, like I said. So guys, I have a video on this. If you've not watched that video, I kindly recommend you to check it out. I'll put a link in the description for your convenience. Thank you very much. Then this is going to be from 1 to n. Good. So this is now going to be 1 over n. That's the limit as n goes to infinity. We have n natural log of n, natural log of n, guys, which is the same as, we plug in the n, we are simply going to have n natural log of n minus n. Great. Then now we subtract it from, we plug in 1, natural log of 1 is simply 0, then minus 1. Wait, we have minus 1. So this is what we have. So this is going to be 1 over n natural log of n into, we now evaluate this, that's we have negative n minus that simply gives us, we have n natural log of n, then we have minus n now plus 1. Great. So guys, if we now multiply n natural log of n inside, we are simply going to obtain this translated into, we have the limit as n goes to infinity, this goes inside, we are simply going to have 1 because it cancels with this now. Then everything now comes in and multiply this guy now. We expect to have negative n plus 1, all that on n natural log of n. Wait, natural log of n. Wait, so this is what we have, guys. So now as n goes to infinity, guys, we see that this part, this negative n plus 1 over n natural log of n, in this case, guys, obviously goes to 0. This whole part goes to 0. So now when n goes to infinity, like I said, this whole part goes to 0. Why? Because the bottom is heavier than the top. The bottom definitely is heavier than the top. And natural log of x, as we all know, is an increasing function, and n as well is also increasing. Likewise, this negative n, if we ignore the negative, we see that n is also an increasing function. The negative makes it a decreasing function, then 1 is just a constant. So everything here goes to 0. So our answer, guys, we just have 1. Great. So guys, this is the answer to this our problem. Guys, this is from the Berkeley Math tournament. Okay, I just saw the question. This is it. Thank you very much, guys, for watching, and don't forget to subscribe to the channel. Please subscribe to the channel and like this video because it does motivate me. Thank you.